Alright, well, to begin our path to discover the actual origins of where the formula for any power comes from, we're going to use the actual classic limit definition of a derivative. Actually, every formula comes from the limit definition. It's just a simplification. So, if you have done this before, you know it's very tedious, and that's why formulas are preferred. But if one actually has a feel for where it comes from, I'm pretty sure the actual process becomes much easier. So let's actually go to it. X to the n, where n can be any power. We're actually going to just evaluate this limit. All right. Well, at first, specifically this part of the limit, it looks pretty hard to get into. How do we simplify this? Well, using precalculus, we're actually going to use the binomial theorem, if you recall, and choose R. There's a sigma in front, but I'm not going to place it right for now. X and minus R, and H in this case will be raised to the R power. Alright, and then where n is your power and R is the amount, the term, zero term, first term, second term, third term, and so on and so forth. Well, I can immediately see what the first term is going to be, and the first term is going to cancel out. So let's actually try this out. So if R becomes 1, in this case, we're going to have n choose 1, and in this case, x is going to be, well, actually, our first term, my bad, is 0. X is going to be x raised to the n. H, in this case, h to the 0 is just 1, so forget about it. We're left with this right here. And choose 0 is 1. I will show you in a moment. So, the first term is x raised to the n. Let's calculate the first two terms so we can see if there's some type of pattern that we can observe and exploit. Alright, so we're going to try n choose 1 now. So we're going to just apply to this formula. X raised to the n minus 1, and then h raised to the first power. So what's n choose 1? If we use the factorial notation, it's the following. Well, we can also simplify this right here. Remember, a factorial is just in this case an integer an integer multiplied by a series of integers, one less than that original integer. Now let me actually describe it. In this case, n, one less integer, n minus 1, n minus 2, and so on and so forth. In the bottom, same thing. It just starts from n minus 1, so it goes all the way n minus 2, and so on and so forth. But now we can actually see that this is going to cancel out, and every term in the future is also going to cancel out. We're left with n. So that simplifies to n. So if we do some house cleaning, we're left with x raised to the n minus 1. In this case, h, that's the second term. That's the first term. And so on and so forth. Well, let's do one more. N choose 2. This is just a binomial exercise. Okay. X n minus 2. H to the second power, same thing, and choose 2, binomial. Okay, same expansion, n minus 1, n minus 2, so on and so forth, and the bottom starts from n minus 2, so everything from n minus 2 forward will be cancelled out. So, I'm going to write this right here. We're left with n minus 1 divided by 2 factorial, which is just 2. So, our third term is going to be n minus 1 to x n minus 2 to the x minus 2 h squared. Alright, let's get these terms together. We're left with x raised to the n plus n x n minus 1 h plus n minus 1 divided by 2 x raised to the n minus 2. Recall, I'm just writing this, h squared, so on and so forth. And then you subtract by minus xn, remember this? Alright, xn will just cancel out. Alright, we're left with this, and the whole thing is divided by, remember, h. Well, h cancels out right here. And if you notice, this term right here is the only term that is going to be without an h. Now we're going to see the consequences of this, and then the other terms are higher than h raised to the first power. So they're always going to have some h power. In this case, this is going to be to the 1, and then the term after will be to the second, to the third, and fourth, and so on and so forth. The important thing to know is that there's always going to be an h here. Okay, now we're going to apply the h, the limit right here. H is going to approach 0. So every term that is multiplied by a 0 is going to cancel out, obviously. So this is going to be left with a 1. If h is 0, this whole thing disappears. This disappears right here. But this term cannot disappear because there's no h. So what you're left over with is n x n minus 1 time, yeah, that's it. And if this looks familiar to you, it should. Power rule.